Good morning, everyone. Welcome to week 2 of our today we'll be talking about inverses of matrices. Right. So inverse of the matrices. This is week 4. We will cover linear algebra until week 6, and then we'll jump on to other sections. Okay. We'll start with acknowledgement of country. I would like to acknowledge the traditional custodian of this land. I pay my respect to elders, past, present, and emerging, for they hold the memories, the tradition, and the cultures of Aboriginal and Torres Strait Islanders people across the nation. Okay, so let's start with recap of what we did earlier. So week 3 recap. So what we did, we talked about determinant, minors, and cofactor. So if you are watching this recording, which I believe you would, if you hear my voice, I would expect you to be proficient in all the concept we covered until week 3. Because what we will cover today is finding the inverse. We'll need a cofactor, and then we'll talk about adjoint. So if you don't know what is a determinant or haven't practiced enough or don't know what's a cofactor, then you will 100% for sure struggle to absorb what we covered today, right? So it's essential that you not just gain the understanding, master that concept, everything that we covered so far, and then jump onto week 4's content, right? It might happen that you get caught up with some assignment, some work commitment, something else, but it's not advised that you go through week 4 unless you have mastered your week 3. We covered some application of determinant in solving the equations and whatnot. We talked about some general properties of determinant. We talked about rank of matrices. That's what we covered. Okay, so let's dive into the next concept of inverse of matrices, the inverse metric. So for any metric A, it has to be, first of all, an n by n metric. Expect for the sentence. So for any n by n metric, if we can find another n by n metric, which is metric B, so the metric B is such that the multiplication of A and B or B and A is the identity metric. And this body B is called the inverse of A, and is written as A inverse, not A power minus 1, but A inverse. Okay. Another thing that you must check prior to any start of the process of finding inverse is determinant A. If the determinant A is non-zero, then only inverse exists. Okay. So it has to be having a non-zero determinant for the inverse to exist. If it is non-zero, yes, you will get an inverse, but if it is 0, it does not have an inverse. So rather than going through the tedious process of finding inverse, first step is we find the determinant of the metric given. If it is non-zero, we say yes, the inverse exists, and this is the process of finding inverse. If it is 0, we stop over there, say because it's 0, inverse does not exist. Okay. So we dive into some properties of inverse. So first of all, a metric A has following property, inverse of metric A. What is it? So number 1, A inverse is the inverse of A. So inverse is A. It's similar to many algebraic property. Negative is plus. So minus 2 of minus 2, right? Minus of minus 2 is 2. 1 over 2. So division is also getting back to the original number, right? This is how it works in linear algebra inverse matrices as well. If A inverse the inverse of A, then A Transpose inverse is inverse transpose. So it doesn't matter if you take the transpose first and then inverse it, or you inverse it and then transpose. They will both give the same outcome. Okay, so once we got the inverse of A, and if you got some non-zero constant C, right? Then we have CA inverse is 1 over CA inverse. So whenever you have a constant multiplied with A, and then you find the inverse, it's the same as 1 over C and A inverse. So this is a very helpful formula because sometimes you might observe minimize number, the smaller are the number, it will be a lot easier, quicker, and accurate to find the inverse. Okay, so this is a very good property, and we'll be using that as and when required. Okay, if A inverse is the inverse of A, B inverse is the inverse of B, then AB inverse is B inverse times A inverse. The last property, if A inverse is A transpose, if the inverse and transpose is the same, right? In other words, A times AT is I. I is identity metric. Yeah, let me clear this one. A times AT is I. A is called orthogonal metric, a name given is a particular type of metric. Okay, now what happens? I mean, it's not like what I'm doing, but just to give you a context, if A times AT is I, right? This A, when it goes on the other side, becomes A inverse. So AT is I times A inverse, right? I times anything, I is identity metric. Same like number 1 in multiplication or number 0 in addition. 0 is the additive identity. 1 is the multiplicative identity. Now we should talk more in terms of mathematical language, right? 0, yes, of course, is a neutral number, but what it is an additive identity number. 1, neutral number, I mean, when I say neutral, it's like identity, that's what I mean, is a multiplicative identity, right? So I times A inverse will give you the same that AT is A inverse, and this is going to be AT is A inverse. Okay. Same thing like basic algebraic property, right? If you got x times 2 is 5, what is x? So you divide both the side by 2, isn't it? So that becomes 5 over 2. Yeah, same thing here. If you got A times AT is I, you multiply both sides by A inverse, and that will give you AT is A inverse, right? So many of the properties of arithmetic or basic abstract algebra, we say it, will be similar to the linear algebra. The algebra that you are seeing is called abstract algebra, and this is called linear algebra. Right. Let's start with an example. So verify that A and B here are inverse of one another. So what we must verify? We should verify that AB is the same as BA is the same as the identity metric. Okay. Before we could verify that they are the inverse of one another, we should start with the determinant. Okay. You can do it in mind as well, right? For a 2 by 2, it's very easy. Principal diagonal minus secondary diagonal. So if I want to talk about determinant of A, it is 5 times 1 minus 2 times 2, 5 minus 4, that's 1, non-zero. Right, similarly, determinant B is 5 times, again, minus 2 times minus 2, that's also 1. That's non-zero. That's what matters. We just want it non-zero. Cool. So determinant A and B are non-zero, and therefore we say that the inverse exists. Okay, and you can do it in a proper way as well. Right. what we have to do is A times B is identity, and so is B times A is identity. Just give it a try. Okay, so like I mentioned at the beginning of the session that you should have practiced week 3 concept. Otherwise, you will understand everything, but you will not be able to do with me. Okay, so again, if you're watching the recording, please pause it here, go back if you're not confident, sorry. Learn the multiplication of matrices or determinant, right? How that everything works, right? So A times B is what we are interested in. A times. So it's a 1, 2, 2, 5, 5 minus 2 minus 2, 1. Okay. If you need help, you can, don't confuse the small letters with the capital. Very soon we'll be observing capital C. Here I'm talking about small c, yeah? This is only to refresh your memory of what we were doing. But I expect by now you would have gained enough proficiency, expertise in multiplication. C11 indicates the first row elements of A are multiplied with first column of B. Before we proceed with multiplication, you should check something, that is the number of column of A should be the same as number of rows of B. If not, if you don't check it, you perform the multiplication, you will be stuck at some point, and that's why it's essential you check it so you don't have to, get if and here and there. Just check this first and then go with the multiplication. They are both square matrices, so it should be fine. Yeah, so we didn't worry about that part. Okay, first row with first column. Now, when you do that, I would expect move your finger. First row, first column, first row, first column. When I talk about C12, first row, second column. So I would go like 1 times 5 plus 2 times minus 2 for C11. C12, first row, second column. 1 times minus 2 plus 2 times 1. C21, second row with first column. 2 times 5 plus 5 times minus 2. C22, second row, second column, 2 times minus 2 plus 5 times 1. Okay. Again, if you need more help, go back and revisit the, I think, week 2 concept where we were dealing with multiplication of matrices. Okay. So 5 minus 4. This is minus 2 plus 2. This is 10 minus 10. And this is minus 4 plus 5. When you simplify that, what is left is 1, 0, 0, 1. That's nothing but identity metric, week 1 concept. Okay. Use this space or this slide to verify BA is equal to I. B times A is equal to I. Okay, so this is your BA is equal to Y. So it's just changing the order, right? And you multiply it, so it goes like this. First row, first column, that's your element here. First row, second column, second row, first column, second row, second column, yeah? And then you simplify it, okay? I would like to give you a tip here, and I really want you to pass it on to your current or future students. What is the difference when it comes to verify, prove, or show? Verify is, it could be right or wrong. Prove is mostly proving theorem or proving something, and show is definitely true, right? So when it's a verify, you have to be careful because answer can be yes or no, true or false. If it's a verify for the same question, if A and B are mutual inverse of each other. So if the multiplication AB or BA is not identity, we say no, they are not inverse of one another. But if it says prove or show that they are inverse of one another, of course, don't close your eyes, but like literally, they are telling you that they are the inverse, show me how they are the inverse, right? So by all means, your multiplication should be the I 1001 in case of 2 by 2. So if you made some mistake, go back and find it, right? Somehow with all authentic means, bring it to I. Okay, that is it. So please pick up that word, like English grammar will help you to identify a correct path, right? Okay. One thing that I'd like to say here, like I want your feedback from anyone watching the recording, right? I had some past feedback saying it's always a mixed approach. I am indecisive, and that's why I'm asking it now. I'll shoot an email or post in a Moodle as well, assuming that you watch Moodle or Teams, Microsoft Teams. What would you prefer? Would you prefer one large recording? Because this is what I think math should be. You can't go to a 4 by 4 inverse unless you're done 2 by 2 inverse, right? Or you prefer multiple parts of recording. So I'll stop the recording here, and there is another file. It's a lot of extra work. I have to upload multiple files, but it's all right. So I would need some feedback. Just shoot me an email, whatever you feel it's convenient to you. And if I still get a mixed approach, I'll try to go extra mile, find some PDF, MP4 cutter, and split the file into multiple parts, right? And upload everything, the bunch, the whole thing, whole recording, which is my favorite, or a bunch of recording, okay? So please let me know if you hear this recording. Right, let's keep going. So finding, so far what we have done is a good process, but with lengthier process, right? So there are multiple ways you can find the inverse, okay? So that's one by definition that AB is equal to BA should be I. Let's find the inverse using the determinant, right? So for an n by n matrix, Aij, if only if determinant is non-zero, the inverse of A is determined by A inverse is equal to 1 over determinant A, mod A. That's how we write it, like this, yeah. Cij transpose. What is Cij? Cij is a metric of the cofactors. Observe is a capital C. That's what I said before a while. In the multiplication A times B, we use a small alphabet C11, indicating first row is multiplied with the first column of B. Over here, we are using capital C, which we used last week for cofactors, right? Okay, and its transpose. So you find the cofactor, replace it in the metric, take the transpose. That's what we call the adjoint A. So the definition for A inverse is equal to adjoint A over determinant A. These steps are intermediate step, which we will surely do it, at least when we are learning it. Okay, right. Now, this is more explanation. What is Cij is a cofactor, right? In determinant A, define that there's a cofactor transpose. So you're talking about power T that indicates the transpose, and adjoint A is nothing but Cij's transpose. This is what it is return, right? So if you observe, our metric is always A11, A12, A13, A1n. Now this one is return in the first column. Why? Because you are talking about transpose. Just to refresh our memory, what is a transpose? Transpose is swapping all the rows and column, right? So first row becomes first column, second row becomes second column, and so on. Right, so let's begin finding the inverse of a metric using 2 by 2. To start with, using determinant for a 2 by 2 metric. Okay, so for 2 by 2, finding determinants is very easy. Principal diagonal minus secondary diagonal. So what is the principal diagonal? Is A11, A22. The secondary diagonal is 21 and 22. Okay, so that will be your determinant A, and that's up here. Right. Now, when you talk about the cofactor, remember what is a cofactor? You remove. Remember, we are talking about minor of that thing. So you remove the row and column containing that element. And whatever is left over, you multiply that with the minus 1 power I plus j. So in terms of 2 by 2, I don't want to go for a lot formally, but just remember in terms of 2 by 2, you will assign this plus minus. And I'll tell you why. This is minus 1 power 1 plus 1. What you are multiplying? This is minus 1 power 1 plus 2. This is minus 1 power 2 plus 1. So what happens? Minus 1 power 2. So that's 1. This is, I will say plus, yeah? Plus, minus, minus, plus. And that's why you got 2 minuses here. Okay, so just remember that for a 2 by 2 metric, when you are finding the inverse using the determinant, this is how we do it. Okay, simply swap the principal diagonal elements, and with the secondary, keep it as it is, but assign the minus. I'll repeat again. In order to find the adjoint of a 2 by 2 determinant, swap the principal diagonal element. Okay, again, swap principal diagonal element, the main diagonal, which we call it, and assign minus 1 to the secondary diagonal. That's it. This is how it's done. Let's look at an example so it makes more sense. Okay, 1, 2, 2, 5. The first thing is, we have just done that one before a while, finding determinant. But the first thing that I would do is finding determinant, because you anyway need it here. Right? The determinant is 1 times 5 minus 2 times 2, and that is 1, which is non-zero. Happy days, we can go ahead and find the inverse, which is that value here. So you need to find it anyway. It's better you start with that value. Okay. Now for the adjoint A. So again, there are many terminology. We start with the minor, then we go with the cofactor, then we transpose the cofactor metric, and that's what we call adjoint A, right? If you're not in a loop of constant learning, you will struggle with this unit. And at the end, you'll feel like, oh, there is a lot. It's a very easy unit. Yeah, you can very easily achieve a high score, provided you follow it all along. If you don't, you will end up struggling and you'll feel like, nah, it's not worth it, you know, but there is some gap. We still have many weeks left. This is just week 4, technically, and 9 more weeks, yeah, before the exam start. Please be with me if you can. Okay? Right. So pick up the element. This is A11, A12, A21, A22. Plug it in here, give the plus minus, and that's it. Right? So what it will be. You can fill the gap here. 1 over 1, A22, like I said, swap the principal diagonal elements. So 5 and 1, minus 2 and minus 2. 1 over 1 is 1, multiplying by 1 doesn't change anything. So A inverse in this case is 5 minus 2 and 1. Okay. Right. Let's keep going. It's a good fun ride. Inverse of a 3 by 3 matrices. So first of all, a determinant. Remember, we had done the determinant by extending 2 columns last week, the week earlier. Yeah, last week determinant. A11, A21, A31, yeah, A12, 2, 2, and 3, 2. Yeah. I'll take some green color. Oops. Yeah. 1, 2, 3, like this. Yeah, they are being added. And I'll go with blue. This one. 1, 2, 3. They are being subtracted. Right? The green ones to be added, and the blue ones will be subtracted. Okay. So this is in A1, 1, 2, 2, 3, 3, 1, 2, 2, 3, 3, 1, 1, 3, 2, 1, 3, 2, minus the blue one. Okay, that'll keep. Now the adjoint A. So with this one, the same plus minus stuff, right? Let me stick to the column. Okay, so the plus minus sign up here will go like this, which is very easy to explain. Plus minus plus minus plus minus plus minus plus, right? Minus 1 power 1 plus 1, minus 1 power 1 plus 2, 1 plus 3. Yeah, it goes like that. Minus 1 power 1 plus 1, 1 plus 2, 1 plus 3. The moment it goes to the even power, that becomes plus. Minus 1 power 2 plus 1, 2 plus 2, 2 plus 3, that is 5 power. Minus 1 power, third row, first column. So 3 plus 1. Minus 1 power, 3 and 2, third row, second column. Minus 1 power, 3 and 3. Yeah, I hope it makes sense. It will not if you're not followed the last week. Yeah, so what are there? That's minus 1 power I plus j, ith row, jth column. Pretty much what we had done in cofactor last week. Okay. Now, when I talk about the cofactors, I will talk about the minus. So what I do technically, highlight, let me highlight that. If I'm talking about the minor of A11, so cofactor, I will hide this first row, first column, just as if it's not there. Whatever remains, that determinant. So what remains here? What remains here? What remains for the first element? A22, A23, 32, 33. That's what remains. And then how do you find that determinant? Is principal minus secondary. Okay. And then assign this plus minus thing. Okay. So that's that whole bit. 2, 2, 3, 3, 3, 3, 2, 2. Why? As I explained here. Here we swap the order. So let me erase that color. Okay. Now what I will do, again, highlighter. I'm talking about the second element, right? It's if it is done in a one step, it's a bit complicated. Don't worry. When I explain the example, I'll do it step by step. Okay. So when I'm saying second element, I'm hiding this much, right? So what remains? Then I'm talking about a determinant A21, 23, A31, A33. Again, that determinant is principal minus secondary. I'll apply this minus sign because of its location and swap it. The first row becomes first column. So that is that element here. Okay, theoretically, it may not sound that thing, but when we do it, we'll do it step by step. It will be a bit longer calculation. Honestly, you find it longer, it's good. The longer it is, the higher marks it will carry, if you think in terms of the exam, right? Okay, so this is how whole metric has been formed. And once you find the adjoint A, you have the determinant D. The inverse is adjoint A over determinant D. Right. So again, this is that. We find the adjoint, and A inverse is adjoint A over determinant A or D. So let's look at an example. Okay, because it will not make sense if you don't practice it. Okay, so let me do, okay, so there are a couple of steps, right? Let me write A inverse first of all. How do you find? Adjoint A over determinant A, right? So we have to find the adjoint. First of all, we have to find the determinant. That's the first thing. Once we find the determinant, if it is non-zero, right, then only we'll find the inverse. Okay, so again, a quick tip here. If the question is for 5 marks or 4 marks, right, obviously you wouldn't be given a question where determinant 0, you do two-step calculation and determinant 0 and you say no inverse. And that's not true, right? Okay, but if it's a 2-mark or 1-mark question for a 3 by 3 determinant, it's more likely tending towards the determinant is 0. Why? Because you wouldn't be given something to find 9 cofactor, find the transpose, put it back, and the determinant, right, for a 1 or 2 marks weightage, right? So again, incline towards the weightage, right? And then if there is any error, trying to fix it. Okay, so we'll start with the determinant first. So as usual, what we do, extend to column 1, 3, 5, 2, 4, minus 4, right? And we do the multiplication, right? So how that will be? That multiplication will be 4 minus 20 plus 12. That's the first part. Then the second part is minus 20 plus 8 plus 6. Okay, so that is minus 4, and this is minus 6, minus of minus. Ultimately, that's 2, which is non-zero. Happy days, inverse exists. So we will write inverse exist. That's it. That's our first step. Okay. Once we find out that inverse exists, the next step is to find the cofactors. Okay. How do you find the cofactors? So let's call it capital C11, which is minus 1 power 1 plus 1, I plus j, right? We hide the first row, first column. Okay, so I use the highlighter here. We hide the first row. What's happening? Yes. And first row and first column. Whatever is left over, we'll take that. So 4 minus 2 minus 4, 1. Okay. Minus 1 power 1 plus 1, so it's just 1. 4 minus 8. So that's minus 4. That's our first cofactor. Okay. Then we go for the next cofactor, C12. What do we do for C12? We hide the first row, second column. First row, second column. Hide it. Minus 1 power 1 plus 2. 5 and 1. Right? That is minus 1 outside. Inside is 3 minus plus 10. And that gives minus 13. Okay. Those who are watching the recording, please pause here and try to obtain all 9 of cofactors and then play it again. Okay. Okay, so what we have computed is C12. I'll write everything else down. If I'm sure you now understand what I was saying, what I was explaining, right? So C13 is minus 32. Sorry, what was it? Not minus 32, definitely. Yeah, minus 32, sorry. Yeah. Then C 2, 1 is 2. C 2, 2 is 6. C 2, 3 is 14. C 3, 1 is 0. C 3, 2 is minus 1. I'll do the last bit again just in case. C3, 3. So what is the outside? Minus 1 power, both this suffix, that is 3 plus 3. Okay, inside is the determinant, which is excluding the third row, third column. So if you go back here, what I will do, I'll clear this highlighter effect, apply another highlighter. I'm talking about 3, 3. So this is gone. This is gone. Okay, so that's the metric 1, 2, 3, 4. Okay, so we write the metric 1, 2, 3, 4. Now for a 2 by 2, the determinant is principal minus secondary. So outside is minus 1 power 6. So that's positive, and that's 4 minus 6. So that's minus 2. So that is your 3, 3, 3. What is the next step? We are talking about edge joint. What is edge joint? Is a transpose of the cofactor. So we put the transpose back. So what are the transpose? The transpose are minus 4, minus 13, minus 32, 2, 6, 14, 0, minus 1, minus 2. It's a transpose which is adjoint A will be first row is the first column, minus 4, minus 13, minus 32. Second row is second column. Third row is third column. Okay, this is a step-by-step process. Again, I'll repeat myself what we have done so far. First of all, finding the determinant. We have yet one more steps to go. Yeah, first of all, finding the determinant, ensuring that's non-zero, that's not equal to 0. Once you find the determinant non-zero, we said that the inverse exists. We find the cofactor of all the elements. That is capital C11, C12, 13, 212, 23, C31, 3233. Write the capital C, not small. Yeah. Right. What is capital C11? Is a cofactor of element A11, first row, first column. So you hide the first column, hide the first, literally use your hands, right? Or use your extra pen or pencil, hide the first row column like I was highlighting it, right? Outside is minus 1 power I plus j, the suffixes. In case of C11 is a 1 plus 1, okay? So that outside is minus 1 square, so being positive, no problem. Inside, what we have? Eliminate the row and column containing that thing, which we hide it already, and the 2 by 2 determinant. How you obtain 2 by 2 determinant? Principal minus secondary. Please watch your plus minus. On top of my head, I mean, don't be on a stat data or something, but 70% of the student make mistake when they are doing plus minus. The another big mistake when you flip over your page. So make sure you start it fresh on the left-hand side of the page. So you have the whole left-hand side and the right-hand side. The moment you flip over, right, or copy over the matrice to the next page, you'll be like, oh, why did I get wrong? And it will be very hard to find out if you're time bound in an exam situation. Okay, so we find all the cofactor, we put it back in the same place, and then it's transposed. What is a transpose? Converting the rows into column, right? There is a transpose function in Microsoft Excel as well. First row being converted into first column, second row, second column, third row, third column, right? So that's your adjoint. Now, this is another way that the book that we are referring from Professor William Guo, that's what he has done. So he's put all the numbers in place. I find a bit scary. Again, that's my personal view to use that because this is like memorizing it, right? If you don't know this thing, if you don't have your formula sheet or the literature with you, what will you do? You'll be stuck. You'll literally see no way out. This is a lot quicker, absolutely. You just plug in the number, but there is a lot of 2233 and kind of this thing, which I look at it, I find, wow, what's happening? But again, you can keep it handy as an alternative tool. Make this as a first habit, first approach, and my longer approach as a second one. It's absolutely your choice. I wanted to provide you with two options. It's up to you to choose any of them. Obviously, why I gave you my approach, because I thought it's better. You are not relying on any formula or the literature. It's just a technique. Find the cofactor, make its transpose, and that's your adjoint A. Right? This will be a lot quicker, provided you have that open book or the literature or the formula with you. Right? Choice is yours. I would never say this is better or the other. Everything comes with its own plus and minus, pros and cons. You are the best judge. I try to provide you as many approaches or methods as I can. Right? Fine. So this is a very joint. That should be similar to what we just obtained. Right? Finally, A inverse is adjoint A over determinant A, that is half. This is your adjoint A times all the element by half. Okay, so that was minus 4 becomes minus 2, 2 becomes 1, 0 doesn't affect, minus 13 over 2 and everything. And you can also verify that A times A inverse is identity. Okay, now when you wanted to verify this identity, I will not use this A inverse form. I will use the half A inverse form. Why? Because when you're dealing in multiplication, it's anyway cumbersome. And if you include fraction in it, it will be hell. I'm telling you, it will be so terrible. You will almost sure make some mistake. Even I would make some mistake. And that's why I'm saying you would make mistake, right? Because you are doing a lot of plus minus thing and your matrices will be like this big. So keep the fraction outside to make your life a bit smoother. When, if at all, you are verifying A times A inverse or anyway fraction, just keep it outside, right? And deal it with later, because when you're talking it's I with the half form, half times the metric will be 2, 2, 2 principal, rest everything 0. Then you multiply it with half. That's a nice decent identity metric. Yeah. So if you follow this approach, this will be half times the multiplication will be 2, 2, 2, 0, 0, 0, 0, 0. Yeah, this is what it should look like. And then you give the half inside, and that will be 1, 1, 1, 0, 0, 0, 0, 0, 0. That's the metric you will get. Okay. But had you not kept half outside, it will be a bit lengthier, complicated, and chances of error are very, very high. Cool. So that's the inverse of a 3 by 3 metric. Okay, we keep going. I mean, I left some slides blank here. That's for you to verify that A times A inverse is I. Okay. Now I want you to practice this. There is a 3 by 3 metric. I want you to find its inverse. So again, pause the recording and find its inverse. I'll quickly repeat the process. What we do, you find the determinant A, make sure it's not 0. You call it D mod A, same thing, right? Should be non-zero. Then you find the cofactor of every element. How do you find the cofactor? For the first element, minus 1 power 1 plus 1. Hide the first row, first column. That determinant will be 4 minus 2 minus 4, 1. Find it, whatever that comes out. Apply that plus minus thing with it. You know? And if, as a shortcut, if you don't want to worry about the plus minus thing, minus 1 power I plus j, remember they start with a plus here. Alternate plus minus plus. Yeah. Minus plus minus plus minus plus, alternate plus minus. That's it. Give it at the end. Okay. Once you find all the cofactor, there'll be 9 of them because there are 9 elements. You put it back in a cofactor matrix, transpose it. That's your adjoint. And finally, whatever the determinant you get, just times it by that number, and that's your answer. Okay. I think the same one. So yeah, I just repeated what I said. Okay, good. Even if you have, I mean, if you're not done it earlier, do it now. Yeah. Right. Please verify this. Yeah, it's a good practice. Everything that you do is for practice. Yeah. The more you do, better you will be. Okay. Okay, so while we pause the recording, since this was a repeated question, we come up with some new metric, so this is already done. So if you have more time, do the same question again, or else this one on the screen, 1 minus 2, 3, 2, 0, 3, 1, 5, 4. What we do is find the adjoint and determinant. The first step is find the determinant. If it is non-zero, we find the inverse, right? We did the whole bit, right? So we first started with determinant. So that's like extending two columns that turn out to be 25. Happy days, we can find the inverse, right? Once you decide that there is an inverse, you have to go ahead and find the cofactors. C11, like we just did, minus 1 power 1 plus 1, eliminate the first row, first column, right? And that's your 2 by 2 determinant, 0, 3, 5, 4. Principal minus secondary will give you minus 15. Then C12, 13, and all rest of 9. Okay, once you get all the cofactor, we will talk about the adjoint. How do you find the adjoint? You put the cofactors there and leave a T on the top. That T means the transpose. What does a transpose do? Converts the row into columns. So the first row becomes first column, second becomes second column, third row becomes third column. And then finally, you leave it as yes. And finally, you leave that one as 1 over 25 and like this, okay? That's your final A inverse. Both of the answers are fine. You can plug that 1 over 25 inside to each of the element, right? Or that can happily stay outside. You don't want your metric to look so messy, right? So you can keep it outside, yeah? Unless it's a specific multiple choice question, either of them is fine. Right, this is an in general formula for A inverse, which is Cij transpose. So you find the transpose of the cofactor and divide by the determinant. And that's your adjoint A over determinant A. Cool. Let's go to that is for 4 by 4, sorry, by the way. Yeah, or any higher, 4 by 4 or higher. Right. Let's try it one more. Let's find it for 4 by 4. So it's definitely your chance to have it a go. So that's your metric, 2, 1, 3, 1, 0, minus 1, 2, 1. It's an upper triangular metric. So I said something about triangular metric earlier. Determinant is just the multiple of principal diagonal element. So determinant is minus 4 very easily, right? Once you find the determinant, then you find the cofactor, which will be a lot easy, even though you have to find a cofactor of 0. Don't assume cofactor of 0 is 0. It has nothing to do with its value. It has to do with its position, right? So when you're finding the cofactor of 0, what you will do is eliminate the row and column containing that element. See, whatever left, you have to find the determinant. Will be a big question. I'll leave it to you guys to try that. And that's about it. Okay. One thing that I will tell you is, right. So what I would do is I would go 4 by 4 plus metric calculator. That's it. Okay, so you go here, metric relation, whatever website, use it with utmost integrity. So don't play trick here. Right, set a metric. Once you set the metric, 2 and 1, then 3 and 1, and 0, minus 1, 2, 1, 0, 0, 1, 2, 0, 0, 0, 2, and calculate. It will calculate its inverse as a final answer. The steps will be a bit different to what we have just learned using adjoint method. You could have to go with some other website. And then if you see, say, show solution, it will do something Gauss elimination method, which we will learn it, right? But it will tell you everything, right? If you wanted to go and find the determinant, again, you go to the same website, set your metric, right? And that will be 2, 1, 3, 1, 0, minus. Sorry, I'll clear this. The number so I can watch it very carefully. Yes, I can. Where's that website? Yes. Okay. 2, 0, minus 1, then 2, 1, 0, 0, 1, 2, 0, 0, 0, 2. It says fill empty cell with 0. So whatever empty cell, you just fill up this, but I prefer having a tab and typing it everything. And it will say determinant -4, which we knew anyway, because we knew it's an upper triangular, and therefore the determinant is the product of its principal diagonal element. That is this. Yeah, that's your principal diagonal. This one, just multiplied. Okay. There could be some other ways of calculating inverse metric method. Let's say this one. And if I go metric transpose, right? Power metric, inverse metric. So we tried inverse, right? Metric addition, subtraction, metric multiplication. Use it just to check your answer, right? This again, we will use it, a bit later on, right? There is something Gauss elimination, right? It's a very helpful and easy website to use, right? Metric transpose, you set the metric and transpose is converting rows into column, right? And then you got metric power. Metric power is a power 3, right? We'll use it for finding eigenvalues and other stuff. Which is beyond the scope of this unit. But yeah, it's a very famous rule. Yes, very helpful. We'll use that. Cool. So this is it. I'll leave you guys to try that. And that's it for today. Thank you very much. I'll let everyone go. Yeah. Any questions, shoot me an email. Yeah. Thank you. Have a good week.